Hello guys and welcome back to Leet Logics. This is the Backspace String Compare question. This is a Leetcode easy and the number for this is 844. So in this question we are given two strings S and T which contains lowercase characters and a special character hash. We need to determine if these strings are equal when typed into an empty text editor and support backspace, where the hash will mean a backspace character. So in this question we can see we have given with this input a b hash c. So in this a is typed, then b is typed, then we have a backspace hash, so b is deleted, and then c. So we can start this question with a straightforward approach in which you can use stack. So we can utilize two stacks s1 and s2 to simulate the typing of both string into a text editor, and if there is a character we can add it into the stack. If there is a hash we can ignore it and also remove the last character which we have added if the string is not empty. So you can see we have visualized the stack approach for you. Suppose we have a string s equal to a hash bc hash d and string t equal to bde. So for string s we process it into the stack. So a comes, a is added to the stack, then hash, so previous character needs to be deleted, a is deleted. Then we have a b, b is added. Then we have a c, c is also added. Then hash, so c needs to be deleted, so c is deleted. Then we have a d, and d is added onto the stack. So the resultant string at the end will be bd. Similarly for string t, which was bde, there are no hash characters, so all the three characters will simply be added to the stack, and afterwards we can empty it into some variables, and then we can compare the variables and return the answer. The next approach which we can use is a two-pointer approach, in which we can start from the end. Like we can start from the D and we can move the pointer to the left side until we encounter a valid character. So initially the pointer will be at D, then the pointer will when move left and find the next valid character. So the next valid character is C, but since we have a hash we have to skip C. So the next valid character will be B, and then B we again have a hash, so the next valid index will be -1. So only B and D will be remaining in this case. So this is the optimal approach. We're using two pointer. I will show you the dry run for this as well. D comes, then hash, then C. C is ignored. Then B comes, then again a hash, and A is also ignored. And for BD it is simple. E comes, then B, D comes, then B comes. So let me show you the uh, stack first solution. So in this we have a stack 1 and stack 2. Then I am iterating on the string S, and if it is a hash I am checking if the stack is not empty. I am doing a pop operation and continuing the current loop. Otherwise I am simply adding the character to the stack. Then I am doing a similar operation on the stack 2 and input T. If the character is hash, and check if the stack is not empty, pop, otherwise add it to the stack. And also we have to empty it into variables, so I have taken two result variables, result1 and result2, res1 res2, and I am simply emptying all the stack 1 contents into res1 and stack 2 contents into res2. So after this we will simply compare the res1 with res2 and return the answer. So this solution was based on stack. This this is the time complexity for this is O of n, the space complexity is also O of n, and the interviewer might expect you to optimize this approach. So in that case you can come up with a better approach that I told you about, the optimized version. You can take two pointers I and j and find the next valid character first. So the next valid character is determined by, like, it's first of all, if there is a hash then compare the left character. Otherwise, if there are uh, character, consider it. So you can see I am moving from the right hand side of the string, and until I encounter uh, the counters as -1, I simply iterate through until I can complete my string. And if at any point I found out that the s dot caret I and t dot caret I is not equal, I simply return false. Now this function returns me the next valid character. How it returns is that we check if the current is not equal to -1 and the string should not be equal to hash. This is a very important, that the current character should not be equal to hash. In that case, we simply do a minus minus, we move to the left, then again we check if the left is a hash, then we again have to do a -1 as well. So that's why uh, we compare and return -1 here. So this was the most optimized approach. This gives excellent runtime. If I show you, beats 100% in times and 99% in memory. The time complexity for this is O of n and the space complexity for this is O of 1. So this is a good approach. Please do like, share the video, and please do subscribe to my channel if you like the solution. Thank you. Have a nice day. Thank you for watching the video.